Let's go to question number 3 now. A load of mass 150 kilograms is pulled vertically upwards from rest at fixed point O on the ground, okay, using a winding drum. Load passes through a point A 20 above 20 meter above O with a speed of 1.25 meter per second. Find for the motion from O to A the gain in the potential energy of the load, the gain in the kinetic energy of the load. Now, they're asking specifically here the gain in the potential energy or the change in potential energy. Now, if we have this question number 3 now. We know this to be 20 meter. They say here that is from rest at point O. This is point O. So the velocity at O is 0. And we go to point A here. Velocity at point A is 1.25 meter per second. Normally, we're going to say that height FO is going to be 0, and the height of A is going to be 20 meter. So from here, we can calculate the gain in kinetic energy. Gain in kinetic energy is kinetic energy. Kinetic energy 2 minus kinetic energy 1. Okay. Well, we know also the mass as 160 kilogram. So that's going to be half times mass. Okay, mass is 160 times the position 2 means 1.25 square. Okay. Minus 0. Why 0? Because the velocity will be 0. Okay. While here, we can calculate this. The gain in potential energy means potential energy for position 2 minus potential energy in position 1. That's going to be the mass times gravity times the height minus 0. Because the second one, we have the height of 0. Okay, Eugene, get me this. And Farrell, get me this. Hello.
The potential energy will be 32,000.
Hold on, sir. My place is dark. Hold on, I have to turn on the light, sir.
Sorry?
32,000.
32,000.
For the potential energy.
Oh, sorry. My bad. Okay, that's going to be easy. Okay.
Wait, sir.
Your house is further than his and you don't understand the weather probably, sir.
Sorry?
It's probably raining, I don't know. It's probably dark outside.
Oh, okay.
Your side in Jakarta, that one probably still sunlight. Sir, sorry. Next period, what do you want us to do? Go back in?
Do more question. Do
Go
more
back
question.
The kinetic energy will be 50,000.
50,000. Okay. Okay. Now, the third question is, the power output is constant. On the part C, given that the work done against resistance to motion, okay, work against motion, okay, is given as 20 kilojoule. That will be the same with energy that is going out. Okay. The time taken for the load to travel is 41.7 seconds. So the time here 41.7. We have to find the power output of the winding dam. What is the power? Okay, because you already have in this form here, I'm going to write the question and this. Okay. KA2 minus KA1 plus PE2 minus PE1 plus energy out. I write it this way because we already have the number. So we have 50,000 plus 32,000 plus 20,000. That's going to be 102,000. That will be easy, right? Up until this point. Now, okay, we can find out the P by writing that P is energy over time. That's going to be 102,000.
Wait, sir, I think
Yes.
the kinetic energy is wrong, sir. Hold on, sir.
Okay.
It's
I don't check here.
It's 125. 125.
Okay.
Not 125,000, sir. Just 125.
Oh, really?
Yeah, because the velocity is only 1.25.
Yes, it is. Okay, so we need to calculate all of them here. Okay, so get me the total then. If this is 125, what's total? 52, 125, right? Okay.
Yeah.
Who's next? Farrell or Felicia? Farrell, I think.
Farrell already.
Already, okay.
Farrell was
So Felicia, what's this? Hello?
1,250.
1,250. Okay. That's it. That is in, the unit will be in watt. Hence, the power is 1,250 watt. Any question? This one? This is the past paper questions. So this is what you are likely to find in the real question. This is a real question, similar to this. If you have no question, I'm going to go to the next question. Okay, next. Question number 4 is not past paper. We're not going to do it then, but we're going to do question number 5. A cyclist and her machine have a total mass of 80 kg. The cyclist starts from rest at the top A of a straight path AB, and free wheels move without pedaling or braking down the path to B. So let's have the question number 5 here. I'm going, it has some sketches, but I'm going to write them exaggerated. I know this is supposed to be only 2.6 degrees. I'm just exaggerating things. And we have here 250 meters. We have the mass here of 80 kilogram. Okay. They start from rest. So here, the initial velocity is going to be 0. And because it's freewheeling without giving energy, then the energy that is inputted is going to be 0. Now, It's given that the cyclist passed through B with the speed of 9 meters per second. Here, the velocity at B is 9 meters per second. Find the gain in kinetic energy. So the first question is, what is the gain in kinetic energy? We call them gain in K. That's going to be Ka2 minus Ka1. That's very, very simple, right? It's going to be, half times mass times the square minus half times mass times 0 square, which is going to be 0. Okay, next is going to be Geraldo, I think. Got me this? Geraldo, are you there?
3,240.
2,240? 3,240.
Yeah.
Okay, good. And loss in potential energy of the cyclist. Okay. Next question, they're asking the loss in potential energy. So that is, if we are asking the loss, means we have to find out what is Ka1 minus Ka2. It's a loss. Why is difference between the gain? If we are calculating the gain, we are calculating what is after minus before. But if you're calculating the loss, it is before minus after. Like about money. If you know you are making a profit, profit is what is your value after minus your value before, knowing that the after will be higher than before. But if you're asking to find the loss, it is before minus after.